Arrays in JavaScript are one of the most commonly used data structures. There's multiple ways you can iterate through the data, manipulate it, or transform it along the way. And in this video, I'll be breaking down all the ways you can do just that. So I have an array set up called Pokemon, and there's 4 different Pokemon within this array. The Pokemon are represented as objects, and the objects themselves have 3 properties. One is name, type, and then level. If I wanted to iterate through this, all I could do is just use a traditional for loop. And then I can console out the Pokemon name. JavaScript provides us with a shorthand version of that for loop we had just wrote. It's called forEach. ForEach is a method on JavaScript array objects, and it takes in a callback function. And this callback function will be called on every index of the array. And this will accomplish the exact same thing that we had just wrote. This will console log the names of the Pokemon. Now there's one caveat here is the traditional for loop has access to an index. If we ever need that, we can change the callback function parameters. Instead of passing in just that current object, we can also pass in an index, which would be the second parameter. So now, like before, we have access to the object that the for loop is currently on, and then the index. If we ever needed to filter through this data, we can make use of the filter method. So let's say that we want to pull out just the electric Pokemon types within here. Let's set up a new array. And then what we can do is do the Pokemon.filter method. This is also a callback function. And any time that callback function returns true, then that object will be inputted into this brand new array. So we're not overriding or changing this original Pokemon array at all. So let's just do a console log of that. And as we can see, the array we just console logged only has 1 electric type, since our original Pokemon array only had 1. And just to confirm that we didn't update the original array by doing this filter, let's do a console log of both of these. Okay, with our new console log, you can see the first one executed, it printed all 4 those Pokemon, and then the second one printed just Pikachu. This next one's a little bit more involved. To illustrate it, I added another property called HP, and this is essentially just how much health points each of these Pokemon have. And I set everything up to 100 initially. So let's give a scenario of I want to figure out how much HP my entire party of Pokemon have. To solve this, we can make use of the reduce function. And what this essentially does is it reduces our entire Pokemon array into a single value. And what this reduce function is taking in is the first parameter is a callback function. This is what's going to be executed on every index of this array. And then the second parameter is a initial value. So we're starting off before even executing the reduce function, we're starting off at 0. Going back to our first callback function, that's taking in an accumulator, and it's taking in an index of this array. So it would be the Pokemon object. The accumulator is what's being passed from index to index, keeping that accumulation. So what it's going to do is just add the current Pokemon's HP to that current accumulator value. If we console log this, we get 400. We have 4 Pokemon, all with HP of 100. The next couple methods involve finding some element within our array. So let's say that if we want to find if our Pokemon party has an electric type Pokemon. So we can make use of the find method. In this case, all we have to do is within our callback function, just check if the Pokemon type is electric. This will return true on the very first occurrence of this electric type Pokemon. So in this case, we only have 1 electric type, so the first index will be returned. So after running this, we can see that our find method is finding the first occurrence of Pikachu. That is the first electric type Pokemon. If we go in here and let's add another electric type Pokemon. If we run this again, we can see it's still returning Pikachu because this instance was the first occurrence of electric type. Now, let's say that we want to see the index of the occurrence instead of the actual Pokemon. We can change this to findIndex using the same callback function. Running this will return 0, which is the index of Pikachu. Now let's say we just want a Boolean value returned in the case that we're checking if our Pokemon party has an electric type. Instead of using find, we can make use of sum. Making use of the same callback function that we had set up, just checking the first occurrence of an electric type Pokemon. This will return a Boolean instead of the object. And this also works like find. It'll return the first occurrence. As soon as these conditions are met, it'll return true. Now we want to make sure our entire party has full HP. We can make use of the every method, and within our callback function, we're just returning if the HP of that Pokemon is at 100%. And this will return a Boolean value of true. To search for an element, we can also use the includes method. Now this works in the same concept as the sum method, but the implementation is slightly different. With the sum method, we're making use of a callback function, an equivalency check that we define. But if we use includes, it's using a basic equal to check. So this is helpful for arrays that contain numbers or strings, but it gets a little bit more complex if you have an array of objects like we do here. So let's give an example of party has Pikachu. Now we have an include setup instead of the sum. This is checking for one object literal with another. So these definitions are different, so this will return false. So what we have to do in this case, we have to actually have some reference to that object literal. So if we pull up Pikachu on our own using a find method, or if we just use an index of the array and pass in Pikachu to this equivalency check here, this will now be true. The last method I'm going to be going over is the map function. This is really helpful if you have an array of data that doesn't quite conform to the shape that you're expecting. So in this case, we have a party of Pokemon as our array, but there's a lot of information that's defined within these object literals. Now, if we only want an array of names, so an array of strings, we can make use of the map function. So we can do Pokemon names, Pokemon.maps, and then just return the data that we want. Now, we can return this in any form that we want. This is just going to return a single string. If we want to create a brand new object, we can just wrap this in a object literal or create a new class around here. It's really up to you. But let's go back to the string and let's console log these. So we have a brand new array, which has just Pokemon names. So each one of these is just a string, not the original object literals that we had set up.